Saltwater chlorination is a process that uses dissolved salt as a store for the chlorination system. The chlorine generator uses electrolysis in the presence of dissolved salt to produce hypochlorous acid and sodium hypochlorite, which are the sanitizing agents already commonly used in swimming pools. As such, a saltwater pool is not actually chlorine-free. It simply utilizes a chlorine generator instead of direct addition of chlorine. Distinction from traditional pool chlorination, the presence of chlorine in traditional swimming pools can be described as a combination of free available chlorine and combined available chlorine. While FAC is composed of the free chlorine ions that are available for sanitizing the water, the CAC includes chloramines, which are formed by the reaction of FAC with amines. Chloramines are responsible for the chlorine smell of pools, as well as skin and eye irritation. These problems are the result of insufficient levels of free available chlorine, and indicate a pool that must be shocked by the addition of 5 to 10 times the normal amount of chlorine. In saltwater pools, however, the generator continuously produces free chlorine ions, eliminating the formation of CAC. Electrolysis burns off chloramines in the same manner as traditional shock. As with traditionally chlorinated pools, saltwater pools must be monitored in order to maintain proper water chemistry. Low chlorine levels can be caused by insufficient salt, higher than normal chlorine demand, low stabilizer, sun exposure, or mechanical issues with the generator. Salt count can be lower due to splash-out, backwashing, and dilution via rainwater. Health concerns. Scientific research has shown that since saltwater pools still use chlorine sanitization, they generate the same unhealthy disinfection byproducts that are present in traditional pools. Of highest concern are haloctones and trialomethanes. Among these, bromoform has been found in swimming pools at up to 13-fold higher than maximum levels set by the World Health Organization. Many people consider saltwater chlorine generators to be a new item. However, manufacturers have been producing salt chlorine generators in the United States since the early 1980s, and they first appeared commercially in New Zealand in the early 1970s. The use of saltwater chlorine generators has however grown greatly since the early 2000s. Many hotels and water parks have converted to saltwater systems. Operation. The chlorinator cell consists of parallel titanium plates coated with ruthenium and sometimes iridium. Older models make use of perforated plates, rather than solid plates. Electrolysis naturally attracts calcium and other minerals to the plates. Thus, depending on water chemistry and magnitude of use, the cell will require cleaning in a mild acid solution which will remove the buildup of calcium. Excessive buildup can reduce the effectiveness of the cell. Running the chlorinator for long periods with not enough salt in the pool can strip the coating off the cell, which then requires an expensive replacement, as can using too strong an acid wash. Saltwater pools can also require stabilizer to help stop the sun's UV rays from breaking down free chlorine in the pool. Usual levels are 20 to 50 ppm. They also require the pH to be kept between 7.2 and 7.8, with the chlorine being more effective if the pH is kept closer to 7.2. The average salt levels are usually in the 3,000 to 5,000 ppm range, much less than the ocean, which has salt levels of around 35,000 parts per million. Typically, salt is poured across the bottom of the pool and swept with a pool brush until it dissolves. If concentrated brine is allowed into the return water system, it can cause the chlorinator cell to malfunction due to overconductivity. Benefits and downsides. The benefits of salt systems in pools are the convenience and the constant delivery of pure chlorine-based sanitizer. The reduction of irritating chloramines versus traditional chlorinating methods and the softening effect of electrolysis reducing dissolved alkali minerals in the water are also perceived as benefits. For some people that have sensitivities to chlorine, these systems may be less offensive. Saltwater pools are cheaper to maintain throughout the year, since salt is significantly cheaper than the commercial chlorines. Downsides are initial cost of the system, maintenance, and the cost of replacement cells. Salt is a corrosive and will damage some metals and some improperly sealed stone. However, as the ideal saline concentration of a salt chlorinated pool is very low, Damage usually occurs due to improperly maintained pool chemistry or improper maintenance of the electrolytic cell. Pool equipment manufacturers will not warranty stainless steel products damaged by saline pools. Calcium and other alkali precipitate buildup will occur naturally on the cathode plate, and sometimes in the pool itself as scaling. Regular maintenance of the cell is necessary. Failure to do so will reduce the effectiveness of the cell. Certain designs of saline chlorinators use a reverse polarity design that will regularly switch the roles of the two electrodes between anode and cathode, causing this calcium buildup to dissolve off the accumulating electrode. Such systems reduce, but do not eliminate, the need to clean the electrolytic cell and the occurrence of calcium scale in the water. As chlorine is generated, pH will rise, causing the chlorine to be less effective. Many systems with chemistry automation can sense the rising pH and automatically introduce either CO2 or muriatic acid in order to bring the pH back to the target level. Automation systems will also manage levels of sanitizer by monitoring the ORP or residue levels of the water. This allows only the needed amount of chlorine to be generated based on the demand. Sodium bromide can be used instead of sodium chloride, which produces a bromine pool. The benefits and downsides are the same as those of a salt system. It is not necessary to use a chloride-based acid to balance the pH. Also, bromine is only effective as a sanitizer, not as an oxidizer, leaving a need for adding a shock such as hydrogen peroxide of any chlorine-based shock to burn off inorganic waste and free up combined bromines. This extra step is not needed in a sodium chloride system, as chlorine is effective as both a sanitizer and an oxidizer. A user would only need to superchlorinate, or increase chlorine production of the cell occasionally. That would normally be once a week or after heavy bather loads. See also, mixed metal oxide electrodes, references.